Welcome to the Opal Star Center, guys. So today we are going to see something about braking containment, which is a very important safety measure we'll be taking. What all the safety measures we'll be taking before opening any containment which is containing hidden energy. So here we are going to concentrate more on the hidden energy systems, which may be the load, flow, temperature, pressure, or any chemical corrosion effects. Those things they are mostly hidden, and sometimes people do not care about that one, or they take care about that one, and what is happening during the course of doing the braking containment, they forget the continuous things which are to be carried over. So we mostly talk about chemical energies which is corrosive in nature, maybe building up later on, those things like that. Take for example, one of the things was they were opening a blind flange, and they started working on that one, and the work went on for one or more than a day, and they forgot that there will be a build up for pressure which will be trapped inside. They continued doing that one, relying upon the first isolation and draining process which they done, and this is what the result of the thing which was happening. There was a pressure sudden release of pressure there, and the guy got injured in his face and eyes. So we don't want these things to happen when we are doing the braking containment. Okay, so let us go. Braking containment, mainly we are going to talk about health and safety, use of engineering drawings, and environmental and corrosion issues, and of course the main issue is the hidden energy, maybe pressure, chemical, and other things there. And some of the gas freeing and cleaning techniques using water flooding, inert gas, steam, and air. Of course, there are so many we are going to discuss which are most commonly used. Some of the testing procedure is a vast area, but we'll be looking after only the salient features which are there. Okay, so whenever you are doing any braking containment, the main issue what we are going to concentrate is paperwork, that is your permit to work, your risk assessment, your job plan, and second thing, you have to isolate and get the isolation confirmation certificate and start draining whatever is contained in there. If it is liquid, you drain that one, and then you do the flushing, that is cleaning and gas freeing, as we discussed, told you earlier. Then finally, before you start your work, you have to do your gas testing. If you do not concentrate on these things, then there bound to be some hidden energy present in the work which you are going to do, and it will affect. That's it. That's what we are given simply. Draining, flushing of the work, and under the work control certificate. So paperwork is the first thing. Sometimes there will be different actions happening at the same time. So some of the accidents happen, just like the Alpha thing in the North Sea which happened. It claimed more than 150 people. And that happened because they were not knowing two different works were being done. One was completed, and they started the work, and it was not ever. So they brought out the integrated safe system of work, where you will enter whatever work you are doing in different parts of your plant, and if it is available, just put that one. If it is not, try to bring that one. If there is a more complex operation, take your P&ID and mark the wherever you want to isolate the places. I saw that in CCD you are doing most of the things there using the P&ID, even marking those things. What are all the hazards which are in there? First is the chemical reactions. Second, maybe leakages and collapses due to pressure, flow. Then accidental spillages because of not properly leakages happened before, and then radiological contamination. See, many places there is naturally occurring radioactive materials present in the area which we are working in. It is created naturally, and it is called NOM, and you got to be careful about that one. Then pyrophoric, pyro is fire, and phorus is powder. Some powders, particularly sulfur-based powders, they can spontaneously get on fire when pressurized air is blown on that one. And gaskets, of course, some of the gaskets are pollution, environmental problem, and health hazards are there. You got to be careful about that one. Explosions and fires, just like the first example we saw that one. If there is a hidden energy, there will be sudden release of pressure. Sometimes fire will be there. Static electricity, whenever there is a flow of moisture against any metal, it will create static electricity. It's bound to create harm to us when we are working. And then asphyxiation. If there is some of the containments are left in that, it can build up, and if it is poisonous, it will create asphyxiation, and a lot of fatal accidents happen because of that one. They were thinking that the area is safe, but they started entering and working in that. Here, when you are working on the pressurized system, we are considering two types. One is more than the atmosphere, one is atmospheric, at the atmospheric pressure. And more concern is to be given when the pressurized system, atmospheric tanks and vessels. Also, as we told earlier, sometimes it can build up. If there is particularly sometimes there will be a lock system, O-rings, sometimes it will get tight and it will start creating build-up of pressure inside. So first you have to do is isolate it from the fluid pressure, the gas pressure which you are doing. Whatever material you are using, make sure you have done the cost analysis, which is control of substances, hazardous to health, and you do that one to make sure that you are dealing with material with proper first aid facilities and whatever emergency requirements are needed for that one, and know about the proper properties of the materials you are going to deal with. The remaining pressure, it has to be brought down as close as to the atmospheric pressure. Some other things like closing the vent, the remaining gas has to be depressurized into a vent or a flare system, as the case may be, and precautions to be taken to prevent the spread of accidental thing. One more thing which you have to be very careful about is the dead legs. Dead legs have caused problems because you have to look into that one and make periodical inspections in the dead legs, because there may be trapped contaminants there. Well, if you are using drawings for draining, it's better because you need to devise some of the aids to bring out the material which is remaining in that one. Sometimes you have to use the portable pump and the internals of the tanks or vessels you must know, because then only you will devise how to drain the things. Okay. Make sure the atmospheric and vacuum vents are blocked, and this is to avoid pulling, because when you create vacuum, sometimes the vessels will collapse. Well, the residual things and the sludge, it has to be disposed according to the government control, pollution control legislations, and you cannot drop it, the hazardous waste anywhere you want, but be careful. Then, once you drain the things, there will be some residual which will be available in there, that we have to clean it. Or sometimes there will be build up, we have to remove the gas which is present in there before we start your work. So most common one is water flooding, but in water flooding you need to be careful that more water is used, the weight may be more than the design weight of the structure which is holding the tank. So make sure that that weight is bearable by your structure. If not, give additional supports before doing that one, and large volume of water is required for that one. Draining and other facilities have to be provided. Further, when you are flushing it with water, make sure that there is no static electricity, because the velocity will be high. To keep the velocity low and keep the nozzles earthed properly, so that the static electricity will not come in there. And water will not remove all the petroleum vapor or liquid and solid residuals. then we have to use some other methods for that one. And the water which you used for draining and cleaning the thing, it will get contaminated. So you got to be careful of disposing the water where you are taking it. Second method that normally we use is the inert gas. Inert gases are gases which will not react easily with the metals. So we use the nitrogen gas, carbon dioxide and combustion gases. Whatever is available in your area according to your risk assessment, you can use that one. This will displace the hydrocarbon and the vapors which are toxic to us. Well, care should be, you have to take the care in order not to induce localized freezing of walls, because there will be expansion of gases there. Well, one more thing, problem with the inert gas while you are using is, as I told you earlier, the pyrophoric. Some of the bursting flames, it will spontaneously catch fire. Some of them will be high sulfur bearing hydrocarbons. Make sure that you do not affect in that area. You got to be taking care of the pyrophoric powders which are present in that. Then bring down the concentration of the flammable vapor less than 4% of the volume in there, so that it will not emerge as a fireproof thing. The third one, make sure that there is some specialized equipments are available, because the normal gas tester which we carry may not be able to measure so accurately to bring it down to 4%. Okay. Then third method we use is the steam. When you want to remove some greasing materials, or you want to remove oily materials, you need to have the steam on that one for cleaning. This will be two types. One is open steaming and another one is closed steaming. Open steaming or closed steaming, whatever method you are using, make sure you cool it down and bring it down to normal temperature before you start your work, because you will get affected by the high temperature there. If it is a closed steaming, make sure that the temperature measurement, how much it is going up and down, you need to take care of that one. Well, again, when you are disposing the removed materials, take care of removal. The last method normally we will use is using the air. Again, while using the air, proper forced ventilation should be there, so that the contaminated vapor is removed so fast. And then you need to take care that, same as in the case of your water flooding, you earth the nozzles properly before you put the air inside to remove the hydrocarbon materials. Well, when you are using the air, the vapor clouds, they are very, very important. You see, vapor clouds can travel by the natural draft of air. It will go in the direction of the air blowing there, and it will be carried on. When they find some sparks, then it will get ignited and there will be a heavy blast. One such incident happened when I was in Saudi. There was a tanker which tilted down, and he hit two vehicles, but none of them got injured. But what happened, the vapor which was emanating from the tanker, it travelled to a certain distance, and away from there was a reliable camp, and it found the ignition in there, and only a few people got injured. It got a blast. It was like an explosive explosion happened there. And fortunately, all the workers there, they were away for their work, so many people they escaped from that one. So that is the danger of water vapor. So make sure that you disperse the vapor clouds, because vapor clouds carry the hydrocarbons into that one. We don't want that to happen. Take care of that one. Well, the third one is, if you are entering after you do your isolation, draining and gas freeing and cleaning methods, if you are about to enter into your confined space, then you need to follow the confined space entry procedures which are in there. Confined space, it's not always fully closed, but there may be a problem of presence of flammable toxic substances in there, less oxygen there, sometimes more oxygen there. It will also create some problems there. Ingress of solids and liquids, you have to be careful, and presence of excessive heat inside the confined space. Well, it may be large pipes, or it may be tanks, vessels, separators, silos, and ducts, and sometimes it may be just an open space, but there may be excavations like sewer pits and other things. Any excavation more than 1.2 meters is considered as confined space. Some places like places above floating roofs and some culverts. One such accident happened. There was a sewer, there were 5 pumps, some contractors were called in. 3 of the pumps were out of order. So it was lying there for quite a long time, I think. And when they went there, they just checked the gas presence outside there, and they wanted to have the work done. So one by one, people started entering. What happened was there was contaminated water, stagnated water present in there, but it was sewage water. When they put their leg in there, it got disturbed, and as I told you in the previous slides, asphyxiation. The methane and other hydrocarbons present in there, which was mixed in there, that made asphyxiation, and all the 3 people fell into that one, and there were no more. Only one guy, I think the 4th guy, he went in there. After 3 days he got recovered. That was the only accident I heard about. That it was an open area. It was open area. So you got to be careful about even open areas if it is a little deeper and stagnated water and other things are present in there. Well, you have to plan, check for the confined entry, and do the level 2 risk assessment, and continuous monitoring of oxygen and hydrocarbons or hydrogen sulfate which is present in there. Do the gas testing and the confined space inspection. The guys who are doing this one should be having entry certificate, and it should be valid. Well, procedures of non-compliance, if anything non-compliance to the confined space entry procedures, that has to be attended properly. Then procedures for level 2 risk assessment, if it is more than that one, you got to be taking care of that one. Emergency response is to be ready for the confined space in case anything happens at that. Entry certificate is not a work permit is separate, confined space entry certificate is separate. Well, normally the people who are entering, they should enter with a winch or hoist. Emergency equipment should be there in case that guy is brought immovable, to bring him back, and harness or lifeline should be there to drag him out. Then, well, we did all these things from where the gas is coming in. Gas is maybe coming from the remaining process, maybe entering from the adjoining plant, maybe it's from the utility hoses during flushing and draining, or from the scale or sludge which is present inside the confined space, and also welding and cutting, sometimes spray painting, sometimes even cleaning. Those will create some of the dangerous gases and vapors which are present inside. So you need to make sure whether you are going to enter with the breathing apparatus or without breathing apparatus. If with the breathing apparatus, you need to make sure that anything above below 20%, you should enter with the breathing apparatus, and make sure that the LEL level is less than 1% if you are not having breathing apparatus. So follow those requirements when you are entering that one. Well, gas testing again. Gas tester, if he is entering, he should enter with the breathing apparatus, even if he is testing there, and entry attendants should be stationed outside because he will be entering first time. We do not know the condition what is inside there. So the AGT, he will be wearing always the breathing apparatus, and if possible the AGT shall wear harness and lifeline, and reviving equipment should be kept ready for emergency purposes. Facilities for rescue in case of emergencies should be available in there. Well, entry attendant. after doing those things, the NT attendant, what he is going to do, he should be coming there and he will be recording the persons who are entering and leaving the confined space. And if it is without breathing apparatus, then you should keep in sight whether the guy is moving here and there. You should have a voice contact, call him, do you want water, do you want any materials, how are you, all these things. Radio contact sometimes it will not be permitted inside. Make sure if it is a proper safeguarded equipment there. Prearranged signals sometimes will be having lifeline signals and other things like I pull the rope 2 times if I feel something like that. Sometimes you don't want to talk because you may be getting affected, distress signals and other things. The guy who is standing outside will also be equipped with the radio to contact any emergency help like first aid or ambulances or fire service or whatever is needed. That has to be taken care. Well, after doing your work, to bring it, restore it, that one, before doing that one, you need to make sure that area is worth withstanding the pressure. So you have to check it below the maximum allowable working pressure. You should not exceed. Make sure that it is properly given in there. Check the test pressure with your test plan and mark the areas in the P&ID where it will get affected in case of problems. Written test procedure should be there, and the medium selected may be hydraulic or pneumatic. Whichever medium selected, you have to use that one. And emergency depressurization route after the testing, it has to be identified. And pressurization should be got up in the steps because pressure can create havoc. Like, see here, this one, it is sitting on the vehicle and suddenly because of the pressure, it took it up. And this guy, you see, he is doing the test with a non-conformed specified flanges. And he is not having any emergency draining facilities. This guy is not having knowing how much pressure he is raising that one. There is no gauge or anything for raising the pressure and measuring it. So these guys were doing that pressure test. It blast out, and this guy, it went there and hit him. This guy lost his head. Right. And so we don't want things like that to happen because pressure is very, very dangerous. And you need to have all the measures, and it has to be gradual, and do not use any unspecified, non-standard equipment in the pressure testing. Pressure testing can be done for different purposes like leak test or semi-leak test. Sometimes even valves and other things you have to repair it. You have to check for the pressure holding capabilities. Well, if it is hydraulic test, then make sure the liquid is compatible and it will not go and contaminate the fluids which you are going to use. Make sure it is less than the auto ignition temperature, because when you are raising the pressure, it will increase the temperature also. And just like the diesel engine which we are using, there is auto ignition will happen, and it is called a diesel effect. Some of the other fluids, they have this effect, so you got to be careful. We don't want accidents to happen. Well, if it is a pneumatic test, make sure it can withhold. Sometimes you have to do the non-destructive testing to make sure the structure is okay, and isolate the sections. If it is a very big structure, just isolate the section, test them separately so that you can keep it under your control, and because it will create more high stored energy when you are doing with the pneumatic pressure testing. Well, the persons who are doing that one, because the work is going to be carried out above the normal working pressure, he has to be properly having sufficient knowledge of what he is doing, and professional experience should be there in testing particularly, and he should take all the precautions which are in there. Just because he is trained, it does not mean that he cannot take the precautions. He should take all the precautions which are needed in there. Well, like communication should be effective. In case if it is a public area, you need to give a public announcement that you are going to do the test in there, barricade all the areas, give warnings, and sometimes if you need it, put patrolling there, keep the proper permit work and do the isolations, vents and safety valves, take care of them, which ones are to be open, which ones are to be closed. Okay. Then while applying the test, it has to be gradually increased and it should not be subject to sudden shocks. It will increase the load on that one. As much as possible, keep it under the ambient temperature. Take care of the thermal expansion. Some of the materials which will be used may be having thermal expansion. Hold the pressure, how long you are holding should be in the test plan, and then it should be reduced to 80% of the test figure. Foundation and supports, we already talked about that one. Make sure that they are capable of withstanding the load and pressure. Adequate venting means of drying, and avoid chilling. Sometimes chilling will happen due to sudden expansion. Well, already we talked about this one. Take care of the reservoirs like accumulators, pump, pulsing dampers, which may be affected by the pressure testing. Well, isolation side, when we talked about that one, they'll be using some of the equipment like this, which may be blind or slip plate, slip ring and spectacle blinds. Then while doing the work, take care of the naturally occurring radioactive material just to cap it. Do not exceed the maximum allowable working pressure if you are doing the testing. And before starting everything, make sure the isolation confirmation certificate ICC is there. And when you are doing the cleaning, gas freeing techniques, make sure the lower explosion limit is below that one. Even if there is some hazard left in there, keep it as low as reasonably practicable. Well, isolation, you will be using single wall isolation, double block and bleed, and control of work, any other thing, diverting, truncating the work. Have a plan, always have a checklist. Do not rely on your mind. Have a checklist. Make sure you tick them what are all available. If it is not available, make sure it is available. Then start doing the work. That's a small idea about your braking containment. Just follow the procedures. As I told you, recap it. Have your paperwork properly, your permit and your risk assessment and your job plan in ready. Give a toolbox talk and make sure the isolation certificate, confirmation certificate is with you with the proper area authority, and do the draining after isolation. Do the draining, flushing, cleaning and gas freeing, well, gas testing. If the work is flowing on to the next day or something like that, if it is you let a gap and starting again, make sure you confirm that it is already out of hidden energies, because hidden energies give us a lot of problems. We don't want to get affected by the hidden energies. Well, all the best for your work. Thank you for listening. Thanks a lot.
Thank you very much.